Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to discuss about a new topic in chemistry that goes by the name chemical kinetics. Now we're going to see the difference between chemical kinetics and some of the topics that we come across maybe in physics, like kinematics, which is going to give us a clue on what chemical kinetics is. So for that case, we shall look at different aspects of chemical kinetics, like the rate laws, and other aspects which we are going to discuss further. So for that case, thank you and welcome. So as we have said, today's topic is going to be an introduction to chemical kinetics. So that is going to be our discussion for today. So I think we make it more visible from that. So it is chemical kinetics. And as I said, specifically when we are discussing about a particular topic, maybe in physical sciences, which is chemistry or physics, there might be some relationship with some of the terms that we may come across. But in this case, it's going to be of essence for us to differentiate between the term kinetics and the kinematics, which of course might sound somehow similar with a slight difference, which might bring some kind of ambiguity, or maybe when we're trying to apply some concepts, which is going to give us some kind of ambiguity. So we can just do that one in a nutshell. So that is kinetics, and this is kinematics. So in that case, there's a difference in that in this second term we have the name ma. So I'm just trying to do this so that maybe we might, as we come across them, we might not have a confusion. So the first term, kinetics, entails the study of or is a branch of chemistry. This is a branch of chemistry, or maybe a branch of still chemistry known as biochemistry, that deals with the study of the rate, or measures the rates of chemical reactions. Whereas kinematics, this is the study of a branch of classical mechanics. This classical mechanics is in physics, that basically deals with the study of mechanical points, the motion of mechanical points, bodies, or a system of bodies. So in this case, this one deals with the study of mechanical points, bodies, or a system of bodies, without regard of their physical properties. Of course, in that case, that's just a simple definition for that, so that we can see the difference. So as well as, in as much as kinetics is a branch of chemistry that deals with the measure and study of the rates of reactions, this one is a branch of classical mechanics or physics that deals with the motion or mechanical aspect of points, bodies, or a system of bodies, without regard to, of course, their physical properties or the other forces which are acting on them. So I hope that there's a difference between the two. Now in our case, we're just going to deal with the first aspect, which of course is a branch in chemistry that deals with the study and the measure or the study of reactions, the rates of reactions. So in that case, we can look at our topic, which is Introduction to Chemical Kinetics. So in an essence, as we have said, that kinetics is the study of the measure of chemical reactions, or the study of the measure of the rate of chemical reactions. Chemical kinetics in that sense now refers to the study of the rate at which chemical reactions take place So in that case, when we are studying about kinetics, we're going to look at maybe how fast a reaction takes place. So there are specific variables that we're going to use. In this case, when we say that how fast a reaction takes place, then we are referring to as another term that we're going to call rate. And of course, from physical aspect or classical mechanics, we know that the term rate might refer to as one variable against another one. Of course, it's a ratio, and we're going to look at that. And in that case, for chemical reactions, when we measure the rate or how fast the reaction is taking place, we're going to look at the different variables, as I have said. And in this case, we are going to look at some aspects of a chemical. Now, if we want to know whether a chemical is maybe stronger or weaker, then we're going to measure its concentration. So the concentration of a chemical determines whether it is going to be a stronger or a weaker one. That is in quotes. So we're going to find specific terms that we're going to use for that. Now in that case, when a reaction takes place, there are different aspects that we're going to look into. I've talked about concentration, and I've said this specifically is a ratio. So we can define concentration from this point as the ratio, or the concentration is the ratio of the amount of solute, per amount of a solution. Now, bearing in mind that we understand the difference between these two terms that we have used here, suppose I have just a container here that consists of some water inside, and then I have a spoon of salt. So if I mix the two, then I will have a solution of, this is common salt, so I will have a solution of sodium chloride. So if I dissolve this salt inside this liquid, then I will come up with what we call a solution. So this salt will be referred to as a solute, and then this final product is referred to as a solution. So in actual sense, when we say about the concentration, it's the amount of this in this particular product that we are talking about. So in that case, in an essence, that's a simple definition of concentration. Concentration, of course, has got its own units, which is used to measure concentration of different types of chemicals. As we say, a chemical is a substance that has got defined composition, or maybe a mixture of other substances. So in that case, when we are talking about concentration of chemicals, is measured measured using the units of molarity. So when we talk about molarity of a solution, we are referring to as it is concentration. And in this case, molarity relates the amount of a solute per liter of a solution. So as we have talked about that solution of sodium chloride, when we are talking about molarity, then molarity is the concentration that is the unit that relates the concentration of the amount of, or relates to the amount of moles of a solution per liter of a solute. So in as much as concentration is the relationship between the solute and the amount of solute and the solution. Now for molarity, specifically, it's a unit that is used to measure the amount of moles, per liter of a solution. So this is moles per liter, which gives us the term molarity. So in actual sense, it is a unit of measurement, moles per liter, which is trying to give specific quantities or the ratios which a chemical reaction can be regarded or referred to as much as concentration is concerned. So for that case, we are also going to encounter some terms in this chemical kinetics, and terms like reaction mechanism. Now, reaction mechanism refers to the step-by-step sequence of step-by-step sequence of element of the reactions, or steps by which the overall reaction occurs. Now, in this case, we can say that there are some chemical reactions which entail formation of sequences of steps, or when the reaction is taking place, it occurs in some kind of a sequence of steps. Occurs in a sequence. For instance, if I want to form maybe CO2, I can react carbon plus oxygen to form carbon 2 oxide, and then upon addition of more oxygen, then I will produce carbon 4 oxide. So this sequence of steps is what we call the elementary reactions, which are in between the first steps from the reactants to the final product. So in that case, the mode of describing, or the way of describing these steps from the initial reactants to the final products in between here, then that's a sequence of steps is referred to as reaction mechanisms. And then we have the relationship between, when we are doing a chemical reaction, for instance, I have the reactants A plus B, and then they are forming products C plus D. And then this set of an equation, we refer to them as reactants. This section of the equation, we refer to it as a reactant, and the other side, this is a product. So there is a relationship between the relative quantities of the substances which are taking part in this kind of a reaction in order to form products. So the ratio between the quantities that is taking place on the reactant sides and the products being formed is what we call a stoichiometric ratio, or a stoichiometry. So it is a stoichiometric relationship between the reactants and the products. This is the relative quantities of these substances taking part in the reaction of forming the products. In that case, of course, we are going to see some other reactions which are reversible, and how they are being represented, and try to see how we can be able to go around them. So for that case, in the introduction of chemical kinetics, it is important for us to study such terms as the rate, concentration, molarity, stoichiometry, etc., so that they will assist us to understand whenever we come across specific terms, what does stoichiometry mean. So in this case, I can say that whenever the reactants and the products are being formed, there are specific quantities, of course, which we are going to learn under the topic of one of our videos about the mole concept. We're going to learn about the reaction coefficients. Of course, I can write here. The reaction coefficients are the whole number integers that we put, which precedes the the formula for the reacting and the product species. Maybe for instance, I can use A for that, B for that, C for that, and small d for that, lowercase. For this case, all these lowercase letters represent what we call the reaction and the product coefficients. So in that case, they denote the number or the volumes of the reacting species and the product side. So the relationship between the volumes of the reactants and the product side is what specifically we refer to as stoichiometry. So in that case, as we have said, that one gives us a clue to what the rate of reaction is. Now, as we said, rate is the ratio of a change of a particular, maybe as I can say, use loosely the term variable. It's the change of one variable over the change of another variable, or the rate at which, as we can find the tendency, or so we can say the amount, the change of the amount of a particular substance over the change in time, maybe from the initial starting point to the end. There are some factors which affect rates of these reactions. Now that we have defined the rate, of course, as quantities or the amount or the degree of something that is measured by unit time. Let's put it here, this is the quantity that's measured of a substance over unit time. So this can be changed in quantity, change in concentration, etc. Sorry for this is a delta implying change. So in that case, if we say that maybe this one has moved from a particular point to another one, the quantity has changed from a particular point to another one over a particular period of time, then we're going to refer that one to as the rate. So that is why we say that rate is a quantity or amount or degree of something that is measured by unit time. Now, in referring to the rate of reaction of substances, then we are going to have this analogy whereby we find that what we are going to measure when a chemical reaction takes place, as I've stated here, the reactants undergo a chemical change or a chemical reaction to form products. So in that case, as time goes by, you will find that the reactants are changing to form a product. They may either be wholly consumed or partially consumed. So that in that case, if a reactant is wholly consumed in forming a product, at some specific point in time, the reactants will be consumed and the product will be formed. So maybe there will be a 0% concentration of the reactants and 100% of the products which are formed. So in that case, there are some factors which are important for us to consider when we are talking about the rates of reaction, and we're going to list a few of the factors that we are going to consider when talking about the rate of a chemical reaction. So the factors to consider when talking about the rate of a chemical reaction. So factor number one is temperature. We're going to see that a change in or a variation in temperature is going to affect the rate of reaction, and then we are going to talk about concentration. Now that we have defined what concentration is, and then we are going to talk about, in case maybe there are gaseous reactants, we're going to talk about pressure, since it affects gases. Now remember, for solids and liquids, when we shall talk about matter, we shall look at the physical properties, and then we shall see that gaseous reactants or products are affected by pressure. So, and then we shall have maybe action of the catalyst. So for some of the maybe biological processes that we're going to encounter as we go by, especially under the study of biochemistry, we're going to see that a catalyst is very much involved in those kind of reaction. And by definition, a catalyst is a substance that is involved in a chemical reaction without it being consumed or without it changing its nature. So for that case, these are some of the factors that we are going to consider when we are going to look at the rates of reaction. And then we are also going to consider about the area or the surface area. This can be the surface area of the reactants or the products, when especially we are dealing with reversible reactions. So in this case, these factors are going to be very important, since they are the factors which are going to affect the rate of chemical reactions. And in this case, of course, as we have talked about, we mentioned an aspect of reaction mechanism, and we say that these are step-by-step or elementary reactions which take place in order to form products. So in that case also, it's going to give us the chemical kinetics is going to give us a clue on why it is important to look at reaction mechanisms. And of course, measurement of the concentration is going to give us a clue on how these reaction mechanisms take place. Now, why is it important for us to study chemical kinetics? So we shall look just at the significancy. Of course, we mentioned this one in a nutshell in our introduction, but of course we shall now define it maybe using a few terms. In this case, chemical kinetics is going to assist us to understand how chemical reactions occur. Reactions. So the study of chemical kinetics is going to understand us, to assist us in having a comprehensive way of looking at how chemical reactions occur. And as I've said about the catalyst, it's going to assist us understand the nature of biological processes. This is especially in biochemistry. So and then maybe we shall look at that last one. And as well, it's going to provide for us evidence of reaction mechanisms. Since now measuring the rate of chemical reaction is of course that's a quantitative process which is going to assist us come up with the evidence of trying to describe the reaction mechanism which are involved in different chemical reactions. So in this case, we shall look at some aspects of what we shall cover during our study of the chemical kinetics. Of course, we have talked about the reaction rates. We shall look at the reaction rates, and then we shall look at the rate laws, some laws which are governing the rate of course, how these chemical kinetics processes are taking place. And then we shall have what we call integrated rate laws, which means there are laws which are having a relationship between themselves in this case of chemical reaction. And then we shall have a look at half-life. Half-life, of course, this term appears in one of the topics in some aspect of the topics in radiochemistry. So half-life, or radiophysics, or radiology, or which is the study of radioactivity. So for that case, we shall look at half-life and the Arrhenius equations. And lastly, we shall look at, of course, we have mentioned about the mechanisms, reaction mechanisms. So these are some of the aspects which we are going to look at under chemical kinetics as we go by. So for that case, as we have mentioned that one, and we have given it a definition for that, we can just look at it in just a nutshell and try to see what is reaction rates. So in this case, how do we determine, as we have said, that the rate is change of a particular, or change of something over unit time, and the reaction, as we know, is that it's the change maybe of a interaction of chemicals when they come together and to form product. So in that particular aspect, then we can ask ourselves, as we were saying that the reaction rate is measure of a concentration over time, then what concentration are we measuring? So in this case, as we said, when we gave a general formula for a reaction and said that A is reacting with B to form C, product C and D, then we have a specific notations that we are going to use for concentrations of different substances, maybe of the products and the reactants. So in this case, there's a notation for this specific concentration. If we are referring to the concentration of A, then we're going to give it as the square brackets of A. So in that respect, if we are referring to the concentration of B, then it's going to be given as the square brackets of B. So the same goes for the products, that's the concentration of C and D respectively, are going to be given in that order. Now for instance, we have maybe a reactant that is forming a product, maybe A forming product B, then we shall indicate the concentration of A as the square brackets of A. This is a reactant, and the square brackets of B is a product. So this one implies the concentration of reactants and products in particular. So how do we measure the concentration of the reactant and the product in that case? Of course, there are two ways of achieving this. So we can measure the rate at which the reactants, of course we said that if this reactant is going to be consumed fully in order to form a product, at the end of the reaction we find that the concentration of A, or the amount of A, is 0, whereas the amount of B is at a whole percentage. Of course, we can just literally use that the concentration, or maybe the percentage of A at the end of the reaction will be 0%, and then the percentage of B at the end of the reaction, which is a product, will be 100%. So this one has been fully consumed to form that product. So for us to measure this one, for the reactant to form a product, it will take a specific amount of time, which is change in time. Of course, we are going to just indicate time as t, and its measurement is in seconds. So there are two scenarios. So we are going to either use the speed at which the reactants disappear, or the speed at which the products appear, in order to find the rate. Now in that case, you find that as we said, the rate of reaction depends on different aspects which you mentioned: temperature, pressure, the concentration, etc. So in that case, when we are doing this particular measurement, it is good for us to do the measurement at the earliest time possible when the reactant starts, and at the earliest time possible when the product has been fully formed. So in that case, as we said, that the rate is a concentration over time. So for a chemical reaction, we have defined the rate as a concentration over the time taken then we have said that the concentration of maybe a reactant A can be given as square brackets of A, and then, okay, let's give example for the equation that we have written for a single reactant and a single product, and then time is given us that. So this particular kind of reaction is going to take place over a specific period of time, and then the concentration is going to vary, maybe of either the concentration of a product or the concentration of a reactant. So in this case, when we are talking about a reactant, of course the concentration is going to decrease since the reactant is being consumed to form a product. So we are going to encounter a situation whereby for the reactants, the rate is being denoted as negative, the change in concentration over the change in time, whereby the negative sign is implying a decrease. So in that case, we are going to have to determine the rate, of course, maybe using a specific procedure which we're going to mention. Now in this case, we know that the units for measurements of concentration is molarity that we have mentioned, and then the units for measuring time is T, which of course is seconds. Now we're going to indicate the units as such. So for that case, this is meters, molarity per second, where we said that molarity is the number of moles per liter of a solution. So as I have said, if we have a reactant A that is forming a product B, we can demonstrate the rate at which the reactants are being consumed and the product is being formed. Now let's look at this particular example of this is a reactant and this is a product. We have said that we note the concentration for the reactants by the square brackets of A and the products by the square brackets of B. So this is a reactant and this is a product. So in that case, if we have a reactant and a product denoted as such, then we can write their rate of reaction as we said that the reactant is being consumed. So it will be a negative delta square brackets of A all over change in time. Of course, we have given the units as molarity per second. So for the product, then its rate as well will be given as, now there is no negative sign which is implying consumption, but there is a positive one, change in delta, that's delta B over change in time. So in that case, this one is when the reactants are being consumed, there's a negative sign here implying that they are decreasing. Now this is a decrease and this is an increase. The reactants are being consumed where the products are of course being formed. Now we mentioned an aspect of stoichiometry. Sorry for that. When we were giving some specific examples, I mentioned an aspect of stoichiometry, of course, where I gave the lowercase letters for A, B, and C. It's A, B, C, and D for a reaction that we had given as an example. So generally you find that maybe if there's a, okay, let me write this. We have reactants A and B reacting to form products C and D. So the reaction coefficients for this, we can give them by using the small letters for specific reactants and products. So these are the reaction coefficients that we have given for reactants A and B and forming products C and D. So in that case, giving the rate for this kind of a reaction, we're going to find that for the reactants, it is going to give this ratio. This is a reciprocal of A, which is a reactant. I mean the reactant coefficient for A, change in the concentration of A all over change in time will be equivalent to the reciprocal. Of course, this is B. Again, it is being consumed of the concentration of B over change in time, which will be equivalent to, now the products, as we have said, since they are being formed, there's an increase, so it's going to be positive, so we shall still have just a positive concentration of C over change in time, which is equivalent to the reciprocal of coefficient of D, concentration of D over change in time. So generally this is an equation that we are going to experience, so the relationship between the reacting species and the product being formed in as much as their rate is concerned. So this general equation gives the rate, the way of determining the rate for a reaction, which is of course entailing the reactants reacting to form the products. So in this case, we're going to have what we call a reaction rate constants. So in several equations that we learn in other subjects, like especially physics, we've got specific constants that we talk about. So in this case, reaction rates as well are subject to reaction rate constants, of course, which we shall look at, but for this case, we are going to look at factors which, as we look at factors which affect the rate of reaction, we shall look at as well as factors that affect reaction rate constant. So these are just similar to the factors that were talked about, but of course we are going to see that these factors are based on different aspects, of course, of chemistry or physical sciences, which may be borrowed from other subjects, but of course it's going to affect all these reactions across. So in that case, we mentioned about temperature, concentration, catalyst, surface area, and then the pressure for gaseous reactants or products. In that case, for the case of temperature, how it affects the reaction rates, this one depends on two theories that, of course, which are used to explain the factors that affect reactions as much as temperature is concerned. Of course, we have what we call the kinetic theory, and then we have what we call the collision theory. So suppose I have particles in a container like this, maybe these gaseous particles, and I try to increase the amount of heat in this particular container, maybe it's enclosed. Now this one states that there will be increase in the speed of motion of these particular particles, and it will lead to what we call more collisions. Now this theory states that the kinetic theory states that increase in temperature means the molecules move faster, so the rate of at which they are going to react will be increased as compared to as when the temperature is low. So at a higher temperature, the reactant molecules will move faster since they possess more kinetic energy, and of course react with one another. So for the collision theory, now this one is a different version whereby we have where the molecules collide, and you find that for that case, when the temperature is increased, it gives them more energy for the molecules to collide, and that aspect of collision, of course, they say that is what leads to a chemical reaction. So for this case of collision theory, when the temperature increases, the molecules collide the more, and then the rate of the reaction is increased. Now for this one, increase in temperature increases the kinetic energy of molecules, of course, which leads to the same kind of argument whereby they say that the more they move, the faster they collide, or the faster they collide, and that is how it increases the rate of a chemical reaction. Now for concentration, that we as well mentioned as factors that affect the rate of a chemical reaction. We talked about concentration. Now in this case, for concentration, you find that when the concentration of the reactants are increased, there's a likelihood of the reactants molecules colliding at a faster rate. So you find that when the concentration increases, the rate at which the molecules collide also increases, so which means the concentration will affect the rate of a chemical reaction. And then of course we talked about an aspect of a catalyst, and I said that the catalyst is a substance that is involved in of course takes part in a chemical reaction, but it's not being consumed. So it fastens or increases the rate of reaction, but it's not consumed or changed in another way during the process. So in that case, catalysts lower what we call activation energy, whereby you find that for a substance to react all the molecules at this particular point, it requires some kind of activation energy, which of course maybe if we say this is a reactant at this point forming a product, it requires specific amount of energy for the reaction to be initiated in order for it to form a product. And this amount of energy is what we call, of course, activation energy. So in that case, the catalyst will of course lower this activation energy which is needed, which means it will increase the rate of a chemical reaction. And then for the surface area, this applies for solid reactants. Now for the surface area, you find that the larger the surface area for the reactants, it increases the degree of contact maybe for the reactants, or if it's reverse reaction for the products to go in the opposite direction. So for that case, and as well we talked about pressure. Now increase in pressure of course increases the amount of collisions of the reacting molecules, so which means it will as well increase the rate of reaction, and the reverse for that case will be true. So in this case, as we have looked on different aspects of an introduction to chemical kinetics by defining what it is, and we have also looked at some factors which will affect the rate of chemical reaction, or the reaction rates, and different ways in which we can be able to demonstrate the concentration of specific substances. The one that we have given as the concentration of A is given as A square brackets of A, and the rate is given as the change in concentration. Of course, we shall have that one. So if we say that A is reacting to form B, then we can write the concentration as the change, of course, as the square brackets of A. This is concentration. And we say that we can indicate the rate by change in concentration of A over change in time. And whenever maybe a negative sign occurs, that one implies that these are reactants which are being consumed. And then if it's a positive, or just a sign that appears, maybe forming product B, this is the concentration of B over maybe change in time. And then it's just a negative, positive sign like that, and which means this is a product being formed. So in that case, that's how we denote change in concentration. And of course, this how we denote change in concentration over change in time. And this whole aspect gives us the rates that we're talking about in this case. So as we have said, the rate is important because this is the way in which we can be able to measure the concentration of the reacting species, and the rate at which the products are being formed. So in that case, that one will give us a clue on how we shall proceed with other aspects of the chemical kinetics. That one was just an introduction that has assisted us to come up with a way of representing, having a stoichiometric way of representing the rates of various chemical reactions generally. And then we have looked at some specific aspects which affect the rate of reactions. On our next topic from this, we shall look at a few examples and some of the specific terms that are being used when we are talking about the rates of reactions. Those ones will include like maybe instantaneous rate and the other examples, of course, which we are going to explore before we move to rate laws. So for that case, guys, thank you. This is it for today. Welcome, and I'd like us to engage in the comment section so that we shall be dealing with some aspects which we have not mentioned yet. I know that this is not comprehensive, but as we go by, we shall be having different topics which are going to, of course, complement on what we have discussed. So for today, thank you. Bye. God bless you.